Morning, guys. I'm just, because I can't see you, I'm just going to try and show you the workings of those two questions that I sent you yesterday, because they are quite hard and I would have explained them on the board. So just to help you understand, so basically yesterday's lesson, you should have learned how to draw a refracting telescope. Now, when you draw a refracting telescope, it's really important you use a ruler. So you have to do it like this. You put in your eyepiece, and then you put, sorry, not your eyepiece, that would be your objective, and then you put your eyepiece in, and then you mark a point, so that's say 2 centimetres there and 2 centimetres there, to show where your focal lengths are going to be. So this is going to be your objective, where the light is going to come in. And this one is going to be your eyepiece, where you're going to receive the light. Okay, now this length from here to that point is the focal length of your objective. And this one is the focal length of your eyepiece. Now, what I would have got you to do if we were in the lesson is I would have got you to have a ruler and stick a lens here and a lens here. And say this would have been 20 centimetres and this one would have been, say, 10 centimetres. So that distance between them would have to be 30 centimetres. And then you would have put your eye here and you would have looked through there out the window and seen that you would have magnified the image. But you would have found that the image is also upside down if you'd looked through your homemade telescope. So unfortunately, we can't do that. So the way to draw one of these diagrams, the first thing, now the PowerPoint's pretty good, but the best thing to do is just do your first one, which kind of goes through the middle like that. So that kind of goes through there. Now that one goes straight through the middle. So that ray of light is coming in here from the this is basically, they say, an image at infinity. And that is coming from infinity and it's hitting that lens and it goes straight through because it doesn't get bent because it's going through the middle. Now this one, on this side, the light does get bent as it passes through the lens. And what you find, is, I'm just going to draw that there, that's going to be, what you find is that then goes through, so what I've drawn is from that point on that line where the focal lengths meet, as it were, I've drawn a little arrow straight down there. Okay, now what I'm going to do is I'm going to join that line. I'm going to then get my ruler and it's going to go through that line there like that and come out there. And then I'm going to do another beam of light that's parallel there. And then that beam of light comes through that same point there, like that. Okay, so it's important that they all go through that point, but they just carry on straight. Can you see? Did you? Now, what happens here is these beams of light come out. So what you do here is you kind of draw a line like this, doing a dotted line from that point there, and that goes up there like that. Can you see like that? And then these beams of light come out parallel to that one, like so. Like so. Like so. So the beams of light then get bent by the eyepiece and then they go into the eye like that. So your head here is here and you see these beams of light coming in here. And you think you are seeing an image over there. That's what your brain's thinking. Now, sorry, just nudged it. Sorry, apologise. Now the rays of light coming in here have an angle they call alpha. And your brain is now seeing rays of light coming in at a much bigger angle, beta, if that's okay. So that alpha is the, nudged again, do apologise. The alpha is the beam of light coming in directly from the object, whatever it is. And then beta is what the telescope has magnified it. So your head thinks now that that image is magnified. So it looks bigger, it appears bigger. Now, when we're talking about things from a long way away, like stars, it's not actually an image, it's more of a blob. But the blob is bigger. Can you see? So the magnification is how much bigger the angle is, which is beta over alpha. So beta being the angle that's been magnified, the image that's been magnified, and alpha is what the original object was coming in into the telescope, into what they call the objective, if that's okay. And what we don't have to prove this, but we know that that is going to be equal to f0 over fe, and that is called the angular magnification. Okay, and at normal adjustment, which is where you get your image, the distance between the objective and the eyepiece is basically f0 plus fe. Can you see f0 plus fe? And that's called normal adjustment. And that is the answer to, you know, the first part of question 1 and the first part of question 2. Often they ask you to draw that. Is that okay? Sorry, I wobbled. Okay, I will go through the next answers in my next clip. Okay, bye.